Okay, let's look at topic 26. Use properties of logarithms to expand the logarithmic expression. So we're going to use the rules of logarithms to expand these logarithmic expressions. So the first one, we have the natural log of e to the fourth over 3. So this is a division problem, so we're going to use the quotient rule. So we rewrite it as the natural log of e to the fourth minus the natural log of 3. Next, we look at this first part, the natural log of e to the fourth. Since we have an exponent, we're going to use the power rule, which places the exponent in front of the log, or in this case, the natural log. So we would have 4, the natural log of e, minus the natural log of 3. Okay, the next problem, doing the same thing, we're expanding. So here we just have the log base 6 of the 8th root of y. So we're going to rewrite the radical form into a rational exponent. So this is going to be log base 6 of y raised to the 1/8 power. Okay, we don't have multiplication or division, but we do have an exponent, so we're going to use the power rule, which simply means that this exponent is going to go in front of the logarithm. So our final answer would be 1/8 log base 6 of y. Our next example, we're going to condense. So we're going to take 2 or more logarithms added, subtracted together, and write it as a single logarithm. This will help whenever we're solving logarithmic equations. So in this case, we have the log base c of m plus log base c of n. Anytime we're dealing with addition, that's the product rule. So what's going to happen is this is going to be rewritten as log base c of m times n. The next, again, we're going to condense. So here we have 1/2 log base 6 of x plus log base 6 of y. So the first thing that we're going to do is undo the power rule, which means that this number, this coefficient, this 1/2 in front of the log is the exponent of x. So we're going to write this as log base 6 of x to the 1/2 plus log base 6 of y. Now keep in mind what a rational exponent means. So we're going to change from exponential form to a radical. So the denominator being 2 means we're dealing with the square root. So here we'd have log base 6 of the square root of x plus log base 6 of y. Our last step is, since we're adding these two together, that means that's the product rule, which means we're going to multiply these two arguments together. So our final answer is going to be log base 6. Now order doesn't make a difference. I'd go ahead and write the y first so it doesn't make it look like the y is underneath the radical sign. So it'd be y times the square root of x. Either order would be fine though. If you put the square root of x and left a little bit of a space and put times y, that would work just the same. Okay, I'm going to skip down to log base 5 of 625 over the square root of x minus 1. So since we're dealing with a division problem, we know we're going to use the quotient rule. So we're going to rewrite this as log base 5 of 625. Since it's a quotient, it's subtraction, log base 5 of the square root of x minus 1. Okay, so again, keep in mind, anytime we're dealing with a radical, we're dealing with a rational exponent. So we're going to rewrite that. So we'll leave for now log base 5 of 625 minus log base 5 of x minus 1 to the 1/2. The 1/2 again means square root. Okay, so now, since we're dealing with a power here, this exponent will go in front of the log. But before we get to that stage, we look at log base 5 of 625. We can simplify this because 5 raised to the 4th power gives us 625. So remember, logarithm represents the exponent. The exponent of 5, that would give us 625. So this simplifies to simply 4 minus. Now again, going back to this, since we have an exponent of 1/2, that's going to go in front of the log. And this x minus 1 will remain inside parentheses. Okay, so the last one, again, we're going to expand. So this is a division problem, which means we use the quotient rule. So we have log base 5 of the square root of x minus log base 5 of 125. Again, we're dealing with a radical. So since it's square root, we're going to change it to a rational exponent. And that exponent would be 1/2, meaning square root. If this were cube root, this would be 1/3. So minus log base 5 of 125. Now here we have a power. So again, we're going to use the power rule. That means the 1/2 will go in front of the log base 5 of x. And for this one, again, since there is an integer in which 5 can be raised to give us 125, we're going to go ahead and simplify. We know that 5 to the 3rd power is 125. So the exponent of 5 that gives us 125 is simply 3. And that would be your final answer.